right, so this week we're going to continue looking at sequences. Remember, sequence is just a pattern of numbers, and you basically got to figure out what that pattern is. Okay, so we try to figure it out, and we also try to get a formula. So that way, if we want to predict another number in the pattern, we can use the formula to do it. So let's just review. So this part, you guys just watch me do this because it's not on your notes, just to review. So the sequences we talked about, last week were called arithmetic or arithmetic sequences. Here's an example of one of those kinds of sequences. In order to get from one number to the next in a sequence, there has to be a pattern, and you have to follow that pattern each time. Last week, the kind of pattern that we had was arithmetic, and it always involved doing one of two things. Okay, that's an example of an arithmetic sequence. So is this one. Does anybody see what the pattern is in the top sequence? What I'm doing each time to get from one number to the next? Yeah?
You're adding 2.
Yeah, I'm adding 2. So if we check, yeah, that's the pattern each time. So we're adding 2. So one type of operation you are allowed to do with an arithmetic sequence is add. Okay. How about in the bottom one? Does anyone see what I'm doing there each time? Yeah?
Going down by 3.
I'm going down by 3. Yeah. 17 minus 3 is 14, minus 3 is 11, minus 3 is 8. Perfect. That's another type of sequence that's arithmetic. To be arithmetic, you have to add or subtract each time. Okay? And that's what we did last week. Does anybody remember what you call the number that you add or subtract each time? The letter we used for it was a D. Yeah, it was called the common difference. Common difference. Again, the letter we usually use for that is D. So in the top one, we would say the common difference is positive 2. And in the bottom one, the common difference is negative 3. Any questions on that? And I think as far as review, I'm just double checking if that's all you really need to know. Common difference, yeah, that's it. All right, so now we're going to take a look at a different kind of sequence called geometric. Okay, with a geometric sequence, you are not adding or subtracting each time. Okay, that's not going to be the pattern. With a geometric sequence, the pattern is multiply. Okay, that's the pattern. So it has to be a constant number. That means it's a number that never changes. You use the same number for the whole problem. And you multiply each term by that number to get to the next one. Right, let me show you guys an example. Actually, we got one down here. 2, 8, 32, 128, 512. That's an example of a geometric sequence. It's usually easier to figure out what you multiply by each time if you look at the smaller numbers. Okay. Looking at the bigger numbers, sometimes it's just a little harder to figure out what you multiply by. But let's look at how we get from 2 to 8. Now, if that's all you had, let's just say you had the 2 and the 8, that wouldn't be enough information to figure out the kind of sequence it is. Because to get from 2 to 8, what could you add?
6.
You could add 6, but then if we look at the next number, we can tell adding 6 again doesn't get me to 32. All right, so in order to see a pattern, you really need to have at least 3 or 4, even 5 numbers to be able to look at it. What's another way you can get from 2 to 8 besides adding 6?
Multiply.
Yeah, what could you multiply by?
4.
Okay, times by 4. right? Let's check it and see if that's the pattern all the way down. So let's do 8 times 4. Yep, that gives me the next one. That's 32. Let's try times 4 again. 128 times 4 again, 512. Yep. So that's the pattern in this one. It's times 4 each time. Now that 4, it has a name. When we have a number that we add or subtract each time, that's called the common difference. When we have a number that we multiply by each time, that is called the common ratio. And last time we used D for common difference. What letter do you think we're going to use for common ratio?
R.
R. Yep. So the common ratio, that's going to be R. Now, let's say you were stuck on this problem and you weren't sure how to figure out what the common ratio is. I'm going to show you how you can find it, and it's very similar to how we found the common difference last week. So to find the common ratio, again, which is just called R, take a term, doesn't matter, any term you want, just don't pick the first one because you're going to need the one before it, and there's nothing before the first one. So to find the common ratio, take a term and divide by the one before it, immediately before it. Okay. So let's pick a term. Let's take 32. What's the term immediately before 32 in that sequence of numbers I circled? 8. So now, on your calculator, if you do 32 divided by 8, you get 4. That's how you find your common. That's how you find your common ratio. Take any term you want and divide by the one that comes immediately before it. If it is a geometric sequence, that number will always come out as the same. In this particular problem, it's a 4. It doesn't always have to be a 4, but in this one it does. Take 512, and what would you divide by if you wanted to find the common ratio? Using 512. Yep, you divide by the one that comes immediately before it, and you get 4. What if I took 8? What would I divide by to find the common ratio? 2. Yeah, that's the simplest one because the numbers are the smallest. If you ever got a different answer, then that means your sequence isn't geometric. Okay, like last week, this wouldn't have worked because the pattern wasn't multiplying, it was adding. Okay? As long as the pattern is multiplying, just take any number you want, divide by the one before it, and that'll give you your common ratio. All right, let's look at this one. Now, difference in this one is here, the numbers were getting bigger each time. Here, the numbers are getting smaller. So what that means is we're probably going to be multiplying by a fraction. Okay. Could be like 1/3 or 1/5 or something like that. Okay, the numbers are going to get smaller. All right, so let's see if we can find the common ratio. Can someone give me 2 numbers I could divide? There's lots of different answers from this pattern that would give me the common ratio.
2.
Tell me what number would go on the top.
2.
I don't see a 2 in any of those.
5.
So to find the common ratio, take a term, which means it has to be one of the numbers in the sequence, and divide by the term that comes before it.
We'll do 240.
Okay, so we could take 240, and what would we divide by?
120. For what it? The term before. 460.
460.
I thought it was like term before, like this one.
So as we read it left to right, the one before it is always the one to the left. The one after it is always to the right. All right, so 240 divided by 460. Let's type it in and see what we get. So 240 divided by 460, that gives me, you know what? I think whoever made that made a mistake because I see the pattern. I think that should be a 480. I think that's the pattern they were looking for. So let's try that. Let's take 240 and divide by 480. That gives us 0.5. Or if you want to write it as a fraction, 0.5 is 1/2. Okay, that's your common ratio. Since we had a little uncertainty with that one, let's check it with a different pair. Can somebody give me two other numbers I could divide from that sequence, just to make sure that it still comes out as a half? Yep?
60 and 20.
Yeah. Take that term, 60, divide by the one that comes before it, and let's see what we get this time. 60 divided by 120, yeah, 0.5. Okay. Now I'm going to do one more just to check the one that I fixed. 480 divided by 960, yeah, 0.5. So that means you are multiplying by 1/2 each time to get from one term to the next. What does this number have to be smaller than for the numbers to decrease each time? You'd have to multiply by something smaller than 1. Yep, exactly. If you multiply by something bigger than 1, they will get bigger.
I know the next one.
Yeah, this I know. Did you make it down okay yourself?
Mm-hmm.
Okay. All right, so that's easy enough to find the common ratio. Now let's see if we can figure out how to find a term somewhere in the middle. Now it's easier to do when they're not fractions, but we are going to do some with fractions. So let's make sure we kind of understand how to do it, even if you already see the pattern. Let's pretend like we don't. All right. To find the missing number, the first thing you want to do is figure out what you're going to multiply by each time. Can somebody give me two things that I can divide from that sequence that would tell me what I'm multiplying by each time? Yeah.
36 and
Yeah, take any term, like 36, and divide by the one that comes before it. Okay. And what does 36 divided by 6 give me?
6.
Gives me 6. Yep. So that is what I'm multiplying by each time. I'm 6. Now, you might have been able to see that because there's no fractions, but once we start getting into fractions, it can be a little harder to see what you're doing. But if you do it the way I'm showing you right now, it doesn't matter if it's fractions or not fractions. This method will help you figure it out all the time. Okay, so the pattern is times 6 each time. So to figure out what's going to go in this box, I'm going to use my calculator. And what would I type in for a calculation to figure out what's going to go in that box?
36 times 6.
Yeah, take the number that we know, 36, and hit times 6, and that gives me 216. Now I can check it, because if I multiply that by 6, based on the pattern of numbers, what should I get?
1,296.
Right, if I do times 6 again, I should get 1,296. If I don't, then that means this number is wrong. Okay. So let's see, times 6, perfect. So 216 is the right answer. Okay. Let's try this one. All right, I want to figure out the number that's going to go in that box. What's the first thing that I have to figure out? And we've been labeling this thing with a single letter. Yep, we're going to find R, common ratio. Can someone give me a calculation I can do based off the numbers right there that will help me to find R? Yep. So 15 divided by what? Negative 5. Perfect. Just don't pick the first one because you need to use one term and then the one before it. There's nothing before the first one. And what do we get if we do 15 divided by negative 5? Negative 3. Okay. So now I know what I'm multiplying by each time. It's times negative 3 times negative 3 times negative 3. So now to figure out what's going to go in the box, can somebody else tell me what I'm going to type in on my calculator? Yeah.
135 times negative 3.
Times negative 3. Yep. So that's negative 405. I don't have a number after the last one to check it with, so I can't check it. But that is the pattern. So negative 405. Anytime your R value has a negative in it, the terms are going to bounce back and forth between negative, positive, negative, positive, negative, positive. Okay. That's the only way they can go back and forth like that, if there's a negative for the R. Okay, so now we had one that we had all positives. We had one that had switching back and forth. Now we've got one with fractions. Okay, so just like we did before, first thing we're going to do is find the R value. Can somebody give me, and we don't even have to worry about doing it by hand, we're just going to use the calculator. Can someone give me a calculation that I could type in, and it'll tell me my R value? So do the same thing we did for the last two. No different. Yeah?
Would you just put the 2 ones at the top and the 4 and the 8 on the bottom, and then multiply the 1 and 1?
So to find R, we have to do this. Take a term and divide by the 1 before it. So we're still going to do exactly that same thing. Let's say these were our terms in our sequence. And we don't even have numbers. How would you find the common ratio there? Assuming that's a geometric sequence.
B divided by A.
Sure, B divided by A. Doesn't matter what B and A are. You just take any term and then divide by the one that comes before it. And then if these were numbers, we could actually simplify it. All right, so let's try this one. What could I put in my fraction to find the common ratio?
1/8
Yeah, 1/8 divided by 1/4. Just take any term and divide by the one that comes before it. So now on the calculator, let's type that in. So that's how I type it in on my calculator, 1/8 divided by 1/4. And that gives me 0.5. And what is 0.5 as a fraction?
1/2.
1/2. This calculator can automatically change it to a fraction for me. I think the ones I usually have out can do that as well. Change your answer to a fraction. If you put in 0.5, I think it should be marked correct either way, unless the IXL specifically says leave your answer as a fraction. Then I would say you need to put in 1/2. Otherwise, 0.5 is okay. Any question on finding R there? Okay, so now the last thing we want to look at is, what if I wanted to find the term in this sequence? Like this is the first, second, third, fourth. If I wanted the 5th term, not a big deal, just take and multiply by 1/2. But what if I wanted the 205th term? Okay. I don't want to multiply by 100-something times to get to that term. So what we want is a formula that if I wanted the 200th term, I can just fill in the number 200, and it would automatically tell me, if I fill in this number, it'll automatically tell me the number below, okay, the actual term in the 200th spot. Okay. Why wouldn't we just want to multiply 190 more times by a half till we get to the 200th term? Why not just keep multiplying by a half to get to it? You could. Anybody have a thought why that's not a great idea? Yeah, we could make a mistake. You're only on term 4. If you got to get all the way to 200, you got 190-something calculations to go. Keep multiplying by a half. What else isn't that great about doing it that way? Yeah?
It would take all day.
Yeah, it's going to take a long time, right? It's going to take a really long time to get to the 200th term. You know, if I had to get to the 6th or 7th term, that's not bad. Right, the 200th? No, I need a better way to do it. Okay, so that's what we're going to come up with the formula. So this is the important formula that we need for this week. Okay, so anytime they ask you to write a formula or write an expression, that's the pattern they're looking for. Okay, there are two things that you need to find and fill in. That's the first one. And that is the second one. A sub 1. Okay, that stands for the first term. So anytime that you want to write a formula, you need to know the very first term in your sequence. R, we've also talked about that one. That's the common ratio. So if you want to write a formula, you need to calculate R using what I showed you guys right there. That's how you find R. N stands for the term that you're trying to find. So if you were trying to find the 200th term, then you would fill in a 200 for the N. If you were trying to find the 300th term, you would fill in 300, because that's the one you're looking for. Okay. Unless they tell you what term you're looking for, you don't have to fill anything in for N. So let me show you what a final answer would look like. That's a final answer. I just made those numbers up. Okay. 3 times 5 to the n minus 1. You cannot do 3 times 5 and write 15. That does not work. You have to leave your final answer just like that. And A sub n, this just stands for the nth term. So if you were looking for the 200th term, this is the notation for how you do it. And then whatever you put in that box, if you put that next to it, I know that it means the 200th term, because that's, you wrote the symbol for 200. A, and then a 200 a little bit lower. Okay, but what's highlighted in green and turquoise there, or aqua, whatever, those are the two important things we need to find. Okay, so let's see if we can do that on this one. So the first thing we have to do before we can substitute into the formula is identify the two things I have highlighted, A1 and R. Okay. So looking at those numbers, can anybody tell me what A sub 1 is? Yeah, 5. 5 is the very first term. If you don't know the first term, you might have to work backwards to figure it out, like if they did something like this. That's a sequence where they didn't give you the first term. You might have to work backwards and figure it out. Okay, but here they gave me the first term. And now, does anybody see what the common ratio is? What are we multiplying by each time to get from one term to the next? Yeah?
3.
Yeah, exactly. You're doing times 3. 5 times 3 is 15. 15 times 3 is 45, and you can keep checking it. But that's exactly what it is. Is that the one I just wrote down? Oh, no. I just made those numbers up above, but that's almost our answer. Not quite. So now, take those two numbers and substitute them into the formula. A sub n doesn't change. What did we just say A sub 1 is? 5 times. We just said R is 3 to the n minus 1. That's your formula. So now if you wanted to know what's the 200th term in that pattern, take the number 200 and fill it in right there. 200 minus 1 is 199, and then you're going to need your calculator to do that out. Okay, so this n minus 1 is an exponent. That's why it's up higher. All right, let's try this one. So step 1, they're asking for an equation. Write down your formula. Okay, so now we know the formula we're going to use. What is the first term? 6. And what do we multiply each time to get from one to the next? Yeah, I think the last one was 3 too. It's not always a 3. Right. So now this stays the same. That stays the same. What's A sub 1? 6 times 3. Now let's finish up, try it, and see if it actually gives us the second term. When I plug in a 2, I should get an 18 if that formula works. Let's see. Let's plug in a 2 for n. What's 2 minus 1? 1. What's 3 to the first power? 3. And what's 3 times 6? 18. It correctly predicted. So now if you wanted to know the 400th term way down here, all we have to do is fill in a 400 for n and do it up. But that's the formula you'll be using. And that's the notes on geometric sequences.